Welcome back to Data Architecture Day, sponsored by the Triangle Area SQL Server Users Group. We are on our penultimate session. We have on the screen right now Hasan Savran's presentation. So Hasan, take it away, please.
Hi, everybody. Thank you, Kevin. Thank you for organizing this, and thank you for having me. I am going to speak about Azure Cosmos DB with you today. And this is a brand new presentation. And well, I'm going to try to go in some details with how actually Cosmos DB is handling your data in backend. Before I start the presentation, I guess let me talk about myself. My name is Hasan Savran, and I am a Microsoft Data Platform MVP for a year now. And I am from Cleveland, Ohio. Currently, I'm working at Progressive Insurance as Business Intelligence Architect. I have some good experience with web development. For 14 years, I've been doing it. And 7 years ago, I started in Business Intelligence group at Progressive Insurance. So I have some experience with data too. So I like to share my experience in my blog. You can actually follow me out there if you like. I try to write about the C# front end, Cosmos DB, and SQL Server, and I try to write at least once a week. You can follow me on LinkedIn and Twitter. I try to be pretty active out there. And if you will have any other questions about this or any other Cosmos DB or SQL Server questions, you can follow me from there too. So let's start the presentation. I'm going to speak about the history of Cosmos DB first. In 2010, Microsoft started Cosmos DB as Project Florence project. And that was mostly for internal project for Microsoft. Microsoft has some big products like Office, like Skype, Xbox. All of those are global products, and users are from all over the place. And they had, a database which they were going to actually share the data, and they did not have any kind of NoSQL database. So they started this project, and they call it Project Florence. In 5 years, they made a stable project, and it was everything working fine. And I think that was the time for Microsoft to actually share this with public and make some money on it. And they published it in 2015, and they called it Azure Document DB. That was a place for devs to store JSON objects in cloud, and they were able to retrieve the data by using a language very close to T-SQL. So people loved it, and everybody was using it, and popularity was going high. In 2 years, Microsoft did not stop working on this project, and they made pretty nice features. In 2017, they had another version of this database, and it was pretty big change. So they changed the name of the project from Document DB to Cosmos DB. And they add all kind of amazing features like global distribution, multi-model, and many others. Microsoft didn't stop from that point, and we are in 2020 now. Every year, they are coming up with new features. So usually when I talk about the Cosmos DB, people say that, oh, that's the new database. But if you look at this timeline here, we are in 2020. So you have a product here almost 10 years old. Well, 10 years old. So it's not really that new anymore. And it's getting better and better every year. Another question I get is like, who's using this? So first one I can give you example is the video games. Video games requires very fast database. And I don't know, you play games, but I was, playing like FIFA or something like that, soccer games. And when there's a lag, you can really tell. And it really affects the online gaming. And Cosmos DB is great for that because it's in cloud and it's very stable and it's very fast database. And also you can scale up and scale down very easily. And you can use the Cosmos DB in games for, like, for example, top list of users, or there are some games, you can buy and sell stuff. So those are the really great places for Cosmos DB to use. And I just saw it last week. Everybody was talking about actually Minecraft is going to start to use the Cosmos DB. Next one is e-commerce. E-commerce websites. Well, the database is really the most important part in the e-commerce, because if database goes down, you cannot sell anything anymore. In the United States, we have Black Fridays. And well, when Black Friday comes up, if your web application is, let's say, if you are selling 100 or 200 products a day, in Black Friday, you might have to sell 1,000, 10,000, maybe 100,000. Can your website handle that? And if your web application goes down that day, you will lose a lot of money. So you need a database which you can scale up very easily and also scale down very easily, because after Black Friday, probably you don't need that much power. Third one is IoT devices, and IoT devices has been really popular lately. And the companies are using them because they want to catch the problems before problem happens. So they are putting those small devices to their, I don't know, cars or any devices, and those devices actually sending the status of the device like every 10 seconds, 1 minute. Really, that depends on your business. That end up with a lot of data, and usually data is same. You have the device ID, you have maybe the date and time, and you have some kind of status code. So you need to push this data to a platform that's, you can use other tools to analyze it. So that's Azure platform is a great place for that, and Cosmos DB is a great database for this. So those are the three main places I can really say that Cosmos DB is in use. Also, another question I get from many people is, why do we need another database? Don't we have enough databases out there? So to answer that question, in 2017, IBM came up with this study, and they find out in 2017 that in the last 2 years, we managed to create 90% of the data in the world. If you think about how old the computers are, in some way, we were able to actually generate 90% of that data in 2 years. That is crazy. And now you might say that, yeah, we have cloud now, we have all kind of pictures, videos. So there's a lot of data out there. And also all those numbers you see in the right side, those are what is happening on internet in a day. For example, there's 5 million tweets happening in a day. Do you think Twitter is using SQL Server or any other relational database for this? That's not going to work. And SQL Server is great, but not for everything. And we need a new database to actually handle this much data. Also, one of the main reasons we have this much data is now we have different device types. So you have a one web application, and that application has to run on the desktop, on the laptop, on your tablet, and on your cell phone. And depending where it works, for example, if you open it from your cell phone, maybe your application is going to start to use the GPS and start to actually create more data than desktop. Also, the customers are expecting more in these days. If you think about it, when you go to Amazon is trying to make their website smarter. So you go to a product page, and on that product page, there are all kind of other stuff that you see rather than the product information. Now actually it tells you, okay, you like this product, I have other products like this. Or there are some other users out there, buying those products, maybe you'll like that. So customers are expecting things like that from other web applications. Because of that, applications are consuming more data now. Also, they are generating more data. And that's kind of, puts pressure on databases. Also, you might create a one web application, and very, simple web application, but you might be solving a problem of many people. And you just push that on Amazon store or the Windows Store or Apple Store, wherever, and you might become a global company in one day because people will start to use your application. You will start to have users from Asia, from Africa, from many other places. So next time you wake up in the morning, you see that you have a lot of users. Well, hopefully you pick a right database for this application, because if not, you will be in trouble. So Cosmos DB is really fixing all of those things for us. So now let's start about how actually Cosmos DB works. Just like any other services of Azure or any kind of cloud services, before you, I guess, start it, you kind of need to pick a data center. Probably this one doesn't show you all the data centers. I'm sure there are more than that, but it's just an example. So the first thing you're going to do before you create the Cosmos DB is, well, where is the database is going to actually stay? So in this example, I am going to actually give you one business example here. Let's say we are building cars. We're building cars, and we are headquartered of one of the big companies in Europe. So that's where we are located. This year, we decided that, well, many other companies are making their cars smarter. So we want to create one model, and we want to actually put an IoT device on it so we can receive and send data to our cars. So for that, we hire a dev team, and we told them, that's the plan. So they started to study, and they start to figure out very easily that we need a NoSQL database here. Relational database is not going to cut it. The next, they are going to look at the NoSQL databases, and they figure out very easily that they need a cloud database. And they say, okay, let's give a chance to Cosmos DB. Let's try it. Our data team is smart. They are picking the right database here. So the first thing they are going to actually do is they are going to create one database, probably in their dev area, dev environment, and they're going to pick probably one of those data centers here. That's where the headquarters is. As soon as they create this database, they actually look at the Microsoft suggestions, and they pick the SQL API, because Microsoft actually suggests, for if this is a new product, they suggest you that you should use the SQL API. There are other models for Cosmos DB, and those are mostly if you are actually moving to Cosmos DB from another databases like MongoDB, Gremlin, or Table API is one of those. So if you have the database and if you want to move Cosmos DB, then you can pick those. But if this is a new product, a new project, you should pick the SQL API. So our dev team is creating an IoT application, and we are going to use SQL API. And we just pick one of those data centers here. And as soon as we created it, Microsoft gives us 99.99% SLA with only one data center. So that's a great number. That's a great start. From that point, our dev team says, okay, let's see actually who is buying this car first. Where are we selling this car? And we look at our sales data, and we figure out that we have customers in the United States, in Europe, and in the west of Asia. So in this case, it's very clear that one database is not going to cut this. We don't want our users from United States to write data to Europe or from Asia to Europe. That's going to be a lot of latency, and that's going to be slow. That's not going to work. But we are lucky because Cosmos DB actually has the option global distribution. So all we have to really do is, well, we need to pick other data centers close to our users and just click one button, and this database will be available wherever you pick, and usually less than 30 minutes. And in this case, if you are a driver in the United States, and let's say you are in somewhere in California here, and whenever you try to write the data, you are going to actually write data to data center closest to you. So our dev team is picking 3 more databases. We are picking one for west of United States, one for east of United States, one for Asia, and we already have one of the Europe in here. So by just doing that, we have right now 4 databases, and they are the same database. One thing changed though. What changed is SLA. Now our availability is even better now. Rather than 99.99, we are 99.999%. It's almost 100. This is great. If one of the databases fails, we have other databases to fail over. So this is great. So our data team is happy, and they have a solution for every problem for now. So let's actually see, let's try to go maybe deeper and try to understand what is really happening in those data centers that we pick. The first thing we know is our data stays on local SSD drives, and they are pretty fast. On top of that, whenever we actually create the database, CosmosDB puts them in partition called physical partitions. So in here, I'm just drawing 2 Lego just to represent the physical partitions here. But really, this physical partition is, we have no control of it. Microsoft manages 100%. And how many physical partitions we are going to have is really, Microsoft is going to control that. And that really is going to depend on, how much data you have. So what is those physical partition actually looks like? This is our physical partition, and if you look at it, we have a replica set in them. We have a leader and 3 followers. Leader is usually the very busy here because it gets all the changes, and also not many people knows that, but all the store procedures actually run by leader. So if you are trying to create store procedures to read data, that might not be a good idea because, well, leader is usually busy and it's good for writing, not reading. Followers can actually read the data just as good as leader. So if you are trying to write a store procedure for reading data, really that's not a good idea in Cosmos DB. If you want to actually use a script like a store procedure, you can write the UDF, and followers can actually run the UDF, and that will be much easier to read the data. So when you look at that, that kind of makes sense why Cosmos DB is this fast, because just as you can see, if you are the web application, try to read the data, you have 4 options here. You can go to leader, you can go to any of those followers and read the data, depending what consoles the level you are picking. But you have options. And for this physical partition to be, I guess, accept any inserts and updates, it must have at least 3 replicas running. If it will, let's say, if 2 followers fails, then Cosmos DB actually kills this physical partition and create a new one. But as you can, if you pay attention in the bottom here, this is for if you don't have the global distribution. If you have the global distribution, you're going to have other physical partitions in other data centers. How is that going to work? Our plan kind of changes a little bit here. So what happens is one of our followers become a forwarder. So in here, we have a Europe, we have United States, East, and Asia. So whenever a change comes to Europe, and let's say we have a new column or the new data came in, it then take the leader, then it's going to go to the forwarder. Then forwarder is going to actually push the data to other physical partitions in other data centers. And that's how the Cosmos DB is going to actually sync the data, and everything is going to be in the same place. So now probably you're going to say that, okay, you are sending the data from Europe to Asia. What if you have the user in both places and try to write the same data or delete the same data? What's going to happen? Doesn't conflict happen? Of course it happens. But you have options. So when it comes to the conflicts in the situation, users might have issues whenever they might try to insert the same data. They might try to update the same data with different information, or they can delete. So what's going to happen when something happens like that is our referee is going to come up from nowhere and say that, well, stop it, we have some problem here. So if you don't change any settings, the default is going to be last right wins. So if we have two users, one in the United States and one in Asia, and if they insert the same exact data, we have some internal columns in every document. And one of them is underscore TS, which is for timestamps. So CosmosDB is going to look at which one is the last one, and that one is going to win. And the older one is going to just delete it. So if you don't change anything, that's going to be your default conflict solution. If you are using SQL API, rather than using the timestamp, you can actually use any other numerical properties you have in the documents. For example, if you have the order ID or any kind of ID, which is a number, it can work the same way, and it will pick the, I guess, the highest number, and it will get that. But that works only for SQL API. If that doesn't work either, and if you really need something, really custom, what you can do is you can create a store procedure, and which will actually handle this conflict. You can put any kind of business logic in it, and whenever actually a conflict happens, you can register the store procedure as a merge store procedure, and we have a queue. Whenever a conflict happens, conflict goes in queue, and from that queue, store procedure is going to run and figure out, I guess, which data is good and which one is not, and the conflict is going to actually resolve like that. So you have options when conflict happens. Next one. This one here I'm going to actually share with you is in preview right now. It's not in generally available yet. And we have actually a new storage system for CosmosDB. All the APIs we have here, you see, all of them is actually write to transactional storage. And the data format is raw store. And since everything is OLTP. So what actually Cosmos DB is delivering us is a new storage system, and all the data is saved as a column store here. If you want to get data from analytical storage, you have to use the Spark API to analyze the data. And what really Cosmos DB does is the data comes into transactional storage, and it just Cosmos DB moves automatically to analytical storage for us if you will enable it. So what is that actually solving? First of all, it solves the ETL problem. Who likes ETL, right? I hate ETLs. You write them, and usually they fail, they crash, something. There's too much dependencies on them, and usually they are for moving the data from one environment to the other environment. And you stay out there, you try to make it like not fail. As you can try as much as you can. The network can be wrong or the database can go down, so your ETL operations will fail. It doesn't matter how good your code is really, and it's pain. It takes time and it takes money. So in this case, as I say before, Cosmos DB is the one which is gonna move our data from OLTP environment to analytical environment, and they guarantee that will happen in 30 seconds. This is great. This is almost like a real time. Whenever it comes to the OLTP, it just moves to analytical drive automatically. Just like the other OLTP is globally distributed. This gives us great isolation between the transactional and analytical. That's a great, architecture, because you don't want analytical to go and actually hit to OLTP database and try to analyze the data. So this actually gives us the isolation between the two environments. So here you can see the prices right now. So as I say before, this is in preview right now, so those might change. But as you can see, analytical is cheaper than transactional storage when it comes to consuming. And for the analytical transactions, actually, you need to pay this price here. So it's not free, but believe me, it will be worth it rather than you try to write your own ETL in anywhere. So at the end, you need to pay something for it. If we compare them, So that was another changes just came actually in transactional storage. This used to be 10 gig for logical partitions, and Cosmos DB changed it to 20 gig. In analytical storage, there's no limit for this. Everything is saved as row oriented in transactional, and analytical everything is column oriented to analyze things better and faster. All the APIs that you pick whenever you are creating the Cosmos DB will write to transactional storage. And for analytical storage, for now, the only option you have is the Apache Spark API. There's another great option in Cosmos DB named Time to Live. This is great whenever you have a retention policy for your data. You might have like, oh, I don't care about this data after 2 years. And you can put the 2 years for this setting, and Cosmos DB will start to delete your data after 2 years for free. The same option is available for the analytical storage because probably you don't want to keep that for forever. So you can actually do the same thing here. You might just keep it in 2 years here, maybe 5 years here. How about the architecture of Cosmos DB? So what does it look like when I create the Cosmos DB database? Whenever you create the database, the first thing the system is going to ask you is the container. In here, you're going to just tell like which API you are going to use. As I said before, if this is a new project, you're going to pick the SQL API. If you are moving to Cosmos DB from any of those databases, you can just pick them, and Cosmos DB will take your MongoDB database, and all of your application will not even know that they are really connecting to MongoDB. They're actually connected to Cosmos DB, and you use the same APIs and same code you write for MongoDB. Each container has store procedures, user-defined functions, triggers, merge procedures, and conflicts. So as I said before, if you're writing store procedures and UDF are in JavaScript. So you have to know JavaScript to actually write them. Also, if you want to write a store procedure, try to make them to write data to store procedure, not to read. If you want to read, you can use the user-defined functions. Triggers are tricky, and many people think that they are like the SQL Server. Well, triggers are, you have to fire them yourself. They won't get fired automatically like SQL Server. So there are two types of triggers. One is the pre, the next one is the post. And you have to do them, you have to fire them manually from the SDK. And then the merge procedures and conflicts, I explain those to you whenever conflict happens, your store procedure runs, and try to fix the conflict. Also, your data. Your data can be named document if you pick the SQL API. Your data name, it can be row if it's a table API. If it's Gremlin, it can be node or edges. Really, that's depending which container type or which API you pick. The naming can be different depending on that. We have, as I say before, have some system-defined properties, and those properties are there for every document. I guess we can compare them to SQL Server's virtual columns. You don't see them, but they are there. And in the bottom of the page, you can see what they kind of look like. So RID is the first one, and that's the resource ID. It's a unique identifier of the item. ETAC is usually used for the optimistic concurrency control, which I'm going to cover that in my next slide, so I'm going to pass that for now. And under TS is the timestamp, and every time something gets updated, timestamp changes. And self is the addressable URL, especially if you are using the REST API to actually connect the Cosmos DB. As you can see, this kind of looks like this is your DB. This is your DB name. This is the collection. This is the collection name. This is the document, and that's the document name. As you can see, this thing is matching your resource ID. So by actually using that with the REST API, you will hit this document directly. That's the self. ID here is the only one that you can overwrite, and you don't have to, but you can. It has to be unique name for each logical partition. It cannot be same for different documents. E-tag is very interesting idea. So E-tag is mostly used for optimistic concurrency. Here's the optimistic concurrency's definition. So what is really it is it really doesn't matter what database you are actually using. Let's say we have two users, and our two users are admins, and they are going to try to update, I guess, maybe a product. So the first user goes in, and to update something, first you have to select the data, and he or she selects it. It comes to the front end, and he or she can see all the information. Our user one is, well, he takes his sweet time, so he's kind of slow. Second person is, well, he doesn't know that the other person is actually updating this data. So he or she actually gets the data and tries to update the same data. Second user is faster than first one, so he just or maybe change the price of the product or anything and updates it. And he's out. The first user has absolutely no idea that happened, and he's still looking the older data. So whenever he is going to actually press the update button, well, what's going to happen out there is really you're going to overwrite the second user if you don't have any kind of control out there. So in SQL Server, what we really use is usually have columns out there like update date. And what you have to do is you have to take that update date to the front end and post it back to the database whenever you are changing it. If the update date matches, then that means that product didn't change. But that really depends on the dev. And that dev has to come up with some kind of solution for that. In Cosmos DB, we have options for that. As I say before, this is actually under underscore E-tag is one of the properties that Cosmos DB has in every document. So if you can use any of those access conditions, they are for the HTTP headers. And if match does work for update and delete. So whenever you have the update, you are actually passing the E-tag that you got. If the E-tag matches, then you update the data. If the E-tag tag doesn't matches, then Cosmos DB actually throws an error 412 HTTP code. You can use if none match or if modify since if you like to. If none match is mostly for getting the data. If modify since is getting the data too. So what really if none match does is it determines whether a refetch is necessary or not. And if modify since is mostly for perform the operation only if the resource has not been modified since the date that you are actually passing. So you have those interesting and very useful options for Cosmos DB. This one, I just put it as a reference because many industries, look for those compliances. And really the only one I kind of know here is the HIPAA. But depending where you are, which industry you are, those things might be important for you if you want to use the Cosmos DB. And those are the Cosmos DBs right now they are supporting. So I don't really have that much to say in here. It's just a reference for you. So that's how the Cosmos DB, works overall. When you pick the Cosmos DB and you start to actually create your containers, you are going to have the first big curve for you is going to be picking the right partition. Picking right partition is very important in Cosmos DB, and it can make your application, your project successful or fail, because everything is depending on partition key in Cosmos DB. When I talk about the Cosmos DB's partitioning, usually I get questions like, oh, it's just like primary key, isn't it? Because primary key is unique and you have to pick something unique. It's not at all. Primary key in SQL Server, you just create a primary key and the key or the combination of keys, you cannot insert the same thing to the table again. In Cosmos DB, it doesn't work like that at all. Or how about the table partitioning of SQL Server? Isn't it like that? It doesn't work like that either. In table partitioning, you pick the left side, right side, and usually people use years or months. You put this month, this partition, next month, that partition. So you have to define when it starts and ends. So that doesn't work like either. So what might happen actually here if we pick the wrong partition for Cosmos DB? For example, let's say we have an e-commerce website and we pick maybe state as our partition key. So we want to actually partition all of them by state. What's going to happen is it might work for Ohio or Kentucky, but for New York, we're going to have a lot of problems because there are going to be more orders out there. And as I say before, there's a limit for partitioning, which is the 20 gig. So if you hit the 20 gig limit, then you are in trouble. We cannot actually add any more data on it. So if you're gonna, use the state and pick the New York as a partition key, for sure you're gonna hit that 20 gig. And you are gonna need to actually move the data and change the partition key, and that's gonna be a big problem for you. Also, you need to check what kind of application you have. Is it gonna be write heavy or read heavy? You want to be sure that the partition key you're going to pick is always in your where clause. Because if you use the partition key in your queries, in SQL Server, it's faster. In Cosmos DB, it's cheaper. So literally, you will pay less if you pick the right partition key. To understanding partitioning, let's actually talk about some real-life things. Here, look at this garage. Everything is organized well. You don't have to be really owner of this garage if I actually tell you, can you go get me the screwdriver here? You really don't need to think that much. You know exactly where the tools are. You can see them and you can get them. And the latency is going to be very, low because you can see it. It's right there. Next one. Well, look at that closet. I wish my closet like that. If somebody tells you, you know what, give me some skirt here or give me this red shoes or, a handbag, everything is right there. It's in front of you. And it's going to be very easy to find the data that you are looking for. This is the best one. I used to be customer service long time ago, and sometimes I was in third time shift. My best, I guess, example was they were calling me sometimes and tell me that, oh, you know what, can you go that server in the data center and try to reset that because they cannot connect it or whatever. Well, they just give me the computer name. But finding that computer was not that easy. I wish my data center was like that. And it was, sometimes it took 20, 30 minutes to just to find a computer to reset it. So I guess my point is you need to organize all the stuff first. How do we do that with data though? If you are the SQL Server person, what really usually happens is devs actually create a table, and hopefully they have the primary key. What happens is they start to push data in it, and maybe in 6-7 months, they have a decent amount of data, but things getting small, a bit slow. They go to the DBA, and DBA say that, yeah, we need some indexes here. So you put the indexes on it. Everything works fast again. So maybe 2-3 years again, later, they come to you and say that, you know what, things are slowing down again. And you look at it and you say that, oh, you know what, I think it's time to give you some partitions. And you create the partitions for it, and everything goes fast again. So, as I said before, you are doing the organizing as needed in SQL Server. In Cosmos DB, it's the other way. You have to actually create the partitions in the front. And by creating the partitions, you are really telling the system that where the data is, and it's going to be much easier to find the data by that way. You really need to look at, as I said before, the partition key should be always in your where clauses. And you need to be careful if it's an application write heavily or read heavily. Partition ID, whenever you create it, it will get hashed in Cosmos DB. And partition ID actually will distribute all the requests. It distributes the storage, and is intelligently route the queries for efficiency. So it's very important in Cosmos DB. Let's remember our example here. As you say, those are the physical partitions here, and I kind of show them as a Lego. Now, actually, I want you to think that rather than Lego, I want to represent them as a container ship. This is just a container ship. There is absolutely no connection between the container technology and this container ship here. So whenever you create the database, Cosmos DB gives you this empty container ship. You have absolutely no rights to change anything on this ship. The only thing you can do is organize it. How are you going to organize the data on it? So as I said before, in our application, we were building cars, and we have IoT device in every car. So it's going to be your responsibility to pick a partition ID for this. What are you going to pick partition for this? Are you going to actually group your data by, I don't know, year of the car, color of the car, model of the car? All of those are not really good examples because, 1 year you might have, I don't know, 1 million cars. Maybe next year you might sell 2 million cars. So the balancing is not going to be good for them. Cosmos DB likes the data smaller, and you should have, more distinct data in partitioning logical partitions. And all of those containers actually represents your logical partitions. So if you put one car in every container here, it's going to be very easy whenever you try to read or write data about that car. If you are sending message from that car, you're going to pass the partition ID, which is going to be probably the VIN number of a car. And as soon as you pass it, Cosmos DB is going to know exactly where this car is. And it's going to find that container, open it, read, write, and it's done. If you are going to pick, for example, the year as a partition ID, then what's going to happen is you are going to have like this huge container with many cars in it. And you're going to say, okay, this is the year, and this is the data, and this is the number of the car. So then the Cosmos DB has to go open this big container and find this car, then write or read the data. It's going to be much, I guess, more power. It's going to need more CPU and more memory for that. Also, when the Cosmos DB is going to give you another physical partition here, which is going to be a second ship, it's going to actually try to balance and move some of this data to the second ship. If they are smaller, it's going to be much easier for Cosmos DB to move them. So scaling is going to be really depending on partition ID too. Let's talk about another example. Another example here is, let's say you have an e-commerce website. What do you have in e-commerce website? Usually you have users. Users have orders, and orders, usually they review them, and well, they need some kind of shopping cart too. So if you really look at that, you're going to end up with a lot of IDs here, right? So you have users. You might have a user ID, location ID of the user. Orders is going to have all of these IDs. All of those are really can be a partition ID, depending what you are trying to solve. Are you trying to list the users? Are you trying to list the products? Are you trying to, it really depends. If you think about the Amazon, when you go to Amazon first time, you pick a category. And when you pick the category, then there's going to be products under that. So I guess my point here is don't be scared about multiplying the same data. It might be faster. In NoSQL databases, you don't need to have the same data once in database. You can have multiple times, and there are many ways to actually sync that data. So don't be scared about that. You can have the same data in many different containers. That's what I mean. All right. So as I said before, IoT devices uses Cosmos DB. And IoT devices, they have their own challenges because usually in IoT device, things are very simple. You have the device ID, you have the date and time probably whenever you are trying to write this transaction, and you have a message. So there are not that many properties out there that you can actually use to, I guess, use as a partition key. And usually IoT devices are, write heavy. They don't really read usually data. But as a user, you need to read the data. You need to analyze the data. So you still need to kind of have a partition ID that you can create later. So you can, I guess, have transactions, or to read the data cheaper rather than searching every container, every partition to find the data. So what do we do in that situation? Well, we have a car, right? So as you can see here, in all those days, IoT devices were not even exist. But guess what? We have some IoT devices here. So what happens when this IoT device is going to actually try to write data to Cosmos DB? What do we have here? Let's say this is our information, our IoT devices. So device ID is Knight Rider 1, and year is 1985, and there are some probably data here about the status or whatever this is trying to write to Cosmos DB, like, I don't know, oil level, this, whatever. So we cannot really use that data as a partition ID anyway. So it looks like we have only two options. Well, in 1985, there was only Knight Rider 1, but in our case, we have many cars. And year really doesn't make sense to us that much. So really, if you pick the device ID as a partition ID, your write will be very fast because all the data is going to go to the same partition. But don't forget one thing, your partition has a limit, which is 20 gig. That means this device cannot generate more data than 20 gig if you use the device ID. If you use the year, well, looks like this 1985. So if you are sure that you are going to generate 20 gig in 1 year, that might be an option. But what's going to actually happen is we can make this much better. Since we have many cars, we can actually try to combine some of this data. Both of them is going to create hot partitions here. So what we can do is we can actually create a whole new property and we can combine them. So we can say that this is the device ID dash the year. So that makes it a little bit better. Or we can do maybe a little bit better. In here, what we can do is we can use the year, device ID, and we can try to create a random number at the end. That will make it really distinct. So maybe that number can be between, I don't know, 0 to 200, and it can be a random every time it tries to write the data. That will, if it's a write heavy, that's going to be a great, I guess, solution. But the problem here is whenever you try to read the data, it's not going to be easy because there's no way that you are going to be able to recreate this partition ID. The next one you can do is a different one. You can use the 1985 and you can actually maybe generate another number and you can just hash the VIN number of the car or the device ID. And from that point, you should be able to generate this one whenever you are trying to read the data. As long as you can generate the partition key whenever you are reading the data, you should be in good shape. Because you are going to need that if you need to analyze the data or you're going to try to look at the data. You want to know the partition key, because if you don't have the partition key in your where clause, as I said before, it's going to be an expensive query for you to run. Well, that's all I have for you today. I hope you learned something new today, and you can reach me from Twitter or LinkedIn, and that's my blog. I try to write once a week, as I say before, and I hope you enjoy it. Thank you.
Hey, thank you, Hasan. So we've got a few questions that I've been holding back until the end here.
Sure.
And it looks like we have a few minutes to cover all of this. About 10 minutes for questions. So if there are additional questions, please feel free to drop them in chat now. Starting from the top, going back to e-tags, does the e-tag prevent overwriting what someone else wrote within the bounds of a transaction?
So if you use the e-tag in the SDK and if you program it, yes, the Cosmos DB, whenever you try to do that, because what's going to happen is, as I gave you example from user 1 and user 2, if user 1 got the data, and let's say our e-tag is 1, and user 2 actually update the same data before the user 1, then e-tag is going to change. So whenever the user 1 is going to actually post the data back, Cosmos DB is going to refuse that and say that your e-tag does not match. So you can actually solve that problem like that.
Okay. Are e-tags the same, or are they an implementation of CRDTs?
I guess kind of, yeah.
Okay, because my question was, you mentioned Cosmos having last write wins as the default, and my initial immediate thought is, well, what about CRDTs? And I go look it up, and it's like, yeah, Cosmos supports, for people who don't know what they are, conflict-free replicated data types. allow you to have an update that is not based off of time, but is still guaranteed to be logically correct. So the general idea is that if you have inconsistency between two nodes or two versions of the data, then both sides can, without having a human involved, decide which is in fact the later copy. What is the correct version of everything?
So I think when you say the last write wins, that's mostly conflict between two partitions. So one data center is trying to write the other data center, and that's when the last write wins actually works. The one that I'm talking about, we are using the same partition, and we have two users using the same data center, and they are trying to actually, I guess, update or insert the data in the same, not the same time, but with the optimistic concurrency. Does it make sense?
Yeah, yeah.
Yeah.
Okay.
The last write wins that's mostly for conflict when you have global distribution between two data centers. So you have a user writing the data or inserting the same data. One is from United States, one is from Asia, and then that case that actually happens. Cosmos DB needs to figure out which one to trust. So that one absolutely, that one doesn't have any kind of connection with the e-text.
Right.
Yeah.
Uh, so the next question, um, can the partitioning criteria be jurisdictions? So to follow up on this question, um, think of a global solution. So you're using country or region as the criteria for partitioning. What are your thoughts on that?
So as I say before, you have 20 gig limit. So if you pick a country, I'm not sure how much data you're going to try to write there, but it cannot be more than 20 gig per country. So really, you should try to pick really a much smaller, I guess, area than a country. So like, for example, the example I gave with the cars, we picked the smallest you can pick, which is the VIN number. So that should have the many distinct values rather than like a country code, I guess.
Okay. And in some of the MPP style solutions, typically that partitioning or distribution key is going to be something that you want to be uh, almost uniform distribution. Does that make sense here in Cosmos as well?
What do you mean by the uniform?
So the classic example, the one that I threw into chat here, was if you think about flight data. If you try to do partition on the origin airport code or the destination airport code, you get a lot of skew because JFK, LaGuardia, O'Hare, Atlanta Hartfield, there are going to be a few airports that are incredibly busy and many airports that are not at all busy. So you'll have huge difference in the number of flights.
That's
But
correct.
if
Yeah.
you do by the tail number, each plane only flies a certain number of times. So the difference between the largest and the smallest in a large data set is probably dozens of rows.
Yeah. You are correct. I mean, you can do it like that as long as you can guess what you have to think about when you're reading the data too. So when you analyze the data, the tail number might not work for you either. So what you can do is if JFK itself doesn't work, as I say before, you can combine maybe JFK, I got maybe the day. You can
Okay.
combine them together as a partition key. So that might be easier to whenever you're reading the data, you might be able to kind of guess that partition key easier.
Okay, so it's less about trying to get all of the partitions working currently and more of trying to ensure that you don't break any limits in terms of data size.
That's correct. And the other thing, rather than just writing the data, you kind of need to think about, are you going to have that partition key when you're reading the data too? That's another important one. Because if you think about if you're analyzing the data, right, and you usually use like dates and other stuff because you pick a large amount of data. So are you going to be able to, I guess what partition key should work for that too?
Okay. Okay. Yeah. My mental model, I guess, was a little different from expectations because I was thinking like an Azure SQL Data Warehouse or Redshift.
Yeah. Yeah.
Next question. Well, before the question, one person pointed out that Knight Rider should have a K. Now he did put a smiley face at the end, so it's
Okay,
okay.
I will check that. Cool.
uh, next real question. Are there any stats on how often you encounter the 20 gigabyte limit? So,
What
have
was
you
it
hit the
again?
20 gig limit before?
No, I've never. Actually, it just changed to 20. It was 10 before. So I think many people were very happy when it increased, but I've never hit that limit.
Okay.
Yeah.
And are there any established strategies or tools to deal with repartitioning? So, like,
I,
let's say that you created a partition that you thought was going to be great, but it turns out that there's a lot more data in there than you expected.
so they actually just came up with some kind of tool that you can easily repartition, but I mean, before that tool, there was no way to repartition. It has to be manually. You have to create another container and move your data from one container to other container, which can be really expensive. So that's why the partition, picking the partition key is very important, because when you figure out that you picked the wrong one, it might cost really a good amount of money to you to actually make it right. So they just actually came up with a new tool, and which makes that process automatically. But I didn't have a chance to kind of look at it yet, but I feel like the way that I explained to you actually does it for you. So what it does is really it just creates another container, and you pick the new partition key, and it moves data from one container to this new container, so you don't need to do this manually. But I think it's going to cost you the same amount of money.
Okay. Speaking of money, there was a question in here. I'll rephrase the question slightly. Is there any form of Cosmos DB which is free?
Yes, there is actually they just published, I don't know, maybe 4 or 5 months ago, you can actually use Cosmos DB free. I think they give you, if I remember right, I think it's 400 request units
It is.
for free. Yeah. So
Yeah.
yes, there is one, and you can use it for free as long as if that limit is good for with you.
Yeah, so there is a free tier. Yep.
Yes.
All right. If there are any other questions in chat, this is a wonderful time to drop them in. Is there a desktop sim? Well, I'll ask. Is there still the Cosmos DB emulator?
Yes, emulator is probably your best friend to develop without using any Azure subscription. For free, you can actually, learn the Cosmos DB on your PC with the emulator.
Okay, great. So what the question referred to, chat, is that there is just an executable that you can download and install on your desktop that will make it act as though you were connecting to Cosmos DB, but without having any Cosmos collections or without even having to be online.
That's correct. So it just works like whenever you create it, it's just an emulator, and it opens in your website, and it kind of looks like the Azure Cosmos DB's website. You can create containers, and it can work for SQL API, MongoDB. It can emulate any of those APIs. And if you don't have Windows, there's a Docker version. You can actually get the Docker version and run it too.
Oh, that's true. I'd forgotten about the Docker version, and you have some blog posts about the emulator, as I recall.
Yes, there are a lot of, I guess, configuration. So whenever you are running, you can run it from the command with special parameters, and you can actually make the, I guess, emulator work different APIs. Or you can, if you have a team, let's say you have 10 10 devs, and you don't want the emulator in each dev computer, you can have a computer and put the emulator there and make it work as the work group, and all dev can actually use the same emulator, so same data. So there's a lot of options you can run the emulator with, but you kind of need all the parameters.
Excellent. So we are getting to the end of the hour. So Hasan, thank you so much for talking to us about Cosmos DB this evening.
No problem. Thank you for having me, and I hope everybody learned something new.
Excellent. Yes, definitely. And if you have any follow-up questions for Hasan, Twitter, LinkedIn are on there, or reach out to me and I can ask him follow-up questions. But in the meantime, we're going to go to intermission as we prep for the final session. So just like, we're all experts at this now. The stream's gonna go down for just a few seconds. We're gonna bring it back up, brand new stream, brand new everything, and then get to a brand new speaker. All right, thanks everybody. Be right back.